Yeah, thanks for having me. It's such a great pleasure to be, sharing some of the technologies that we're developing at Baidu, especially on the autonomous driving and driverless technologies with everyone here who are attending the meeting. So today I'm gonna just talk a little bit about the Apollo, the open source software, autonomous driving software platform first, and then we will just dive a little bit into the technologies and algorithm and models and neural networks in the software stack. So Apollo made its debut in about 4.5 years ago.
Hello, Jinghao. Sorry to interrupt you. Maybe you can show another view. Now you have the presenter view.
The presenter view. Okay.
You can maybe change another view.
Let me see. Probably not.
Yeah, maybe you can play the keynote first, then just share the.
Yeah, I was trying to do that.
View.
Oh, I see. Okay, got it. How about now?
Okay, good. Thank you.
All right, sure, no problem. Yeah, sorry about that. So Apollo was first introduced in about 4.5 years ago in the year of 2017. So over the past 4.5 years, so Apollo has been evolving through different versions, and the capability of autonomous driving has also been evolved. So starting from the very beginning, we were able to drive on a closed venue in the very beginning. And then gradually we added and expanded the capability of autonomous driving to like fixed lane autonomous driving, and then some simple urban roads at low speed, and then highway, and then regular urban roads. In the most recent Apollo release, which happened last year in the year of 2020, we released some of the specifications and the technologies which is related to the full autonomous driving, which is everybody probably just referred to it as L5. Apollo is now becoming the most popular open source software platform with over 600,000 lines of codes, where you actually check out the code on GitHub. And a large amount of developers, over 45,000 developers around the world, are using Apollo. They either learn the source code, or they download the source code and deploy that on some of their experimental devices, or they use the Apollo as a reference to develop some new algorithm, etc. And also we are working closely with over 110 partners globally to especially on the commercialization area, to enable some of the partners to achieve autonomous driving through the source code that we provided, as well as the cloud services that we provide to our partners. And all those partners are within over 97 countries globally. Apollo is actually a very complicated system. Everything you see right now on GitHub is the open software platform, but other than that, we do have different layers of technologies which is required to be able to run the Apollo entire software stack. At the very bottom, we have this vehicle reference platform, meaning that if you want your vehicle or any mobile devices moving devices to be able to run Apollo, you have to be compatible with the Apollo software standards. In China, we have this certification program, and we have a dedicated team to work closely with you to certify your vehicles and verify if this is truly compatible with the Apollo software stack. But you can do everything on your own as well, because we have all the documentations and specifications. On top of that, we have the hardware development platforms. So on this layer, we're actually working closely with a lot of partners, especially the hardware and sensor vendors globally, to use their sensors and drive those sensors on our autonomous driving vehicles. We also have some in-house developed sensors as well. We use the parts from our partners, and we assemble them, and we have some in-house devices as well. For example, the Apollo sensor unit, which is assembly services, which you can integrate with multiple sensors and provide a unified outputs to the onboard computers, etc. And on top of the hardware layer is our open source software platform, which is the source code you can see on the GitHub. And majority of our development and the involvement and iterations are done on this level. So meaning like you can definitely check out the code and study the algorithm and improve it, and also provide the feedback that you have. And at the very top layer is our cloud services, where we are running our, like for example, our simulation and map generation and our data platforms on. In China, we run the services on the Baidu public clouds, and in the US, we have that services in the Microsoft Azure cloud as well, to provide some of the data required services. Our major customers or users or audiences of Apollo software platform is the colleges and research institutes. So that's why we work closely with a lot of colleges, universities, and researchers to help them with the research and explorations in autonomous driving area. For example, we do provide some of the training courses to get the graduate students and professors to be familiar with the Apollo's software and the algorithms. And also in China, because our software is very well modularized, meaning that you can just take either one piece of it or just a couple of pieces from the entire software stack, and then integrate that with your own devices. For example, this little moving vehicles, and then you can run our source code in it. And also we work closely with different universities and researchers and research institutes to help them with their research purposes. On the commercialization side, we work closely with a lot of commercial partners to, for example, in the mining industry, some of the huge mining trucks are adopting the autonomous driving technologies. Especially, we also have some cloud services where you can do your fleet management. You can do a lot of like monitoring, fleet scheduling services, etc., using our platforms and cloud services. We used to work closely with one of the minibus manufacturers in China to release the first version of the full autonomous driving minibus. And then we kind of expand this commercial relationship with that manufacturer to Robobus. It's relatively bigger, but more like a BRT system where you have a dedicated lanes in the city and urban roads to run your autonomous driving buses. Especially in the year of 2020, Apollo is helping a lot of partners, commercial partners, to fight against the COVID-19. This is a very critical period of time where a lot of partners are facing the needs, especially the surging needs of contactless delivery and sanitization services. So during that period of time, especially the last year, we provided the free microcar turnkey solutions to those commercial partners, so they can just simply adopt the autonomous driving technologies in their either the food delivery or grocery delivery service vehicles. And also we have this cloud services which are completely free to our partners to help build their autonomous driving vehicles and to achieve the contactless services. So that's the brief introduction about what Apollo is, and especially the 4 layers of the software stack, and also the roughly the technology. So what is under the hood? What is the technology and algorithm behind those the entire software stack? As I mentioned, like on GitHub, what you can check out is our source code, primarily the map, localization, perception, prediction, planning, control. Those are pretty much standard modules in a lot of autonomous driving software stack. So what we're going to do is just dive a little bit into some of the technologies that we're developing in those modules, and all those technologies and algorithms are we do have the publication of those algorithms, so you can check out those papers that we published. If you have any question about those papers, you can definitely contact me, and then I can provide more in-depth communication and discussion with you. So, for example, in the perception, in the year of 2020, ECCV will publish this paper, the generalized and scalable approach for 3D lane line detection. Different from the traditional lane line detection, so we use one unified framework to do the image encoding, and also do the geometric reasoning and 3D lane line extraction. And this is the first time we introduced a very advanced lane line detection in three-dimensional space, and it works pretty well. And the source code is published in the GitHub code repo, and also the algorithm and the neural network are in the code as well. At the same time, we released a synthetic data set, which you can definitely download them from our website and verify your algorithm, and also verify the algorithm that we published. On the prediction side, the prediction is actually a very tough question to solve in the autonomous driving technology. In our prediction framework, we developed the algorithms based on different scenarios. For example, we have different neural networks to handle the detection in the junction as well as on the straight roads. And also we also absorb some of the technology developed by some other tech companies, for example, Uber and Waymo, to help increase our capabilities. For example, we in our prediction, we encoded the semantic map. This idea actually came from Uber, and we kind of modify it and improve that and integrate that into our prediction modules. And also we encoded the lane relationship, for example, the neighboring lanes, into a lane graph. This is actually a very early version of the VectorNet that Waymo released 2 years ago. So this is more like an early version of the VectorNet. And we use different neural networks and models to handle the different scenarios. So we had the two papers published in IV 2020 and IROS 2020 targeting those different scenarios and issues and questions. On the planning side, we know like there are different companies or different researchers that are adopting different technologies to deal with the planning. There's one big categories of one big group of users they're trying to use the optimization algorithms to tackle the planning problems. And then there's another group of researchers and developers that they're trying to use the data-driven technology, for example, the deep learning or machine learning algorithm to tackle the planning algorithms. So we never gave up any possibilities. So on the optimization side, we had two papers published in the IB 2020 and ITSC 2019. Basically, we formulate the planning algorithms into a set of optimization problems with different objective functions at different stages with different constraints, and try to tackle those optimization problems and solve and resolve those issues as a real-time problems. So you can definitely check out those papers. And on the other side, we also try to use the data-driven and the machine learning technology, especially the deep learning when deep learning is widely used in motion planning. So similar to like TrophaNet that Waymo has introduced in the past couple of years, we also explore the possibility of using the imitation learning to tackle the autonomous driving problems, especially on the planning, motion planning side. So we had a paper published in IROS 2021 this year, trying to explore and research the possibility of how to drive like a human. So you can definitely, you're more than welcome to check out those papers and let us know your feedback. And this is the new experiment and the new research areas that we are focusing on right now. And maybe in the future, we're gonna have more and more planning research on the planning side using the deep learning algorithms and neural networks to tackle this tackle these issues. And also, there's one specific areas about the planning, which is the open space planner. So open space planner is, this scenario is slightly different from the on-lane planner where you have very structured road structures. In the open space planner, meaning that you don't have a lot of structured information about the areas that you'll be driving. And you just simply have a very, you simply have a boundary where you cannot go beyond those boundaries, but within this boundary, you're freely to move around. So we formulated this, the open space planner into a MPC problem and try to tackle this problems using two different algorithms. And our goal is to resolve those issues on the real time, meaning that the system, the algorithm has to be deployed on the vehicles, and during a very short period of time, these algorithms needs to generate the reasonable and safe trajectories. So yeah, so OpenSpace Planner has a wide applications in the autonomous driving as well. For example, like pullover and the dead end and 3-point turn, and all those scenarios, you can actually use the OpenSpace planners to solve those scenarios. And we also had two publications about these algorithms. One is in ACC this year, and the other is on the GAL, which is a journal paper. And also, because we're using mostly the, if we want to verify our algorithm, we are heavily rely on our simulation services. So without a very accurate vehicle dynamic models, you cannot make the control in the loop, meaning that whatever algorithm that you develop, it has to be installed and deployed on the real vehicle, which may pose some potential threats, because not all the algorithms were very well tested. So that's why in order to achieve this control in the loop simulation, we spend some time developing some vehicle dynamic models and deploy that models together with the simulation platforms so that you can actually test your control algorithm in our simulation environment. We evolved two versions of the vehicle dynamic models using the deep learning. And all those technical results were published in the IROS 2019 and 2021. You can actually check out those papers about how accurate our vehicle dynamic models and how they are running on our platforms. And all those models are deployed in our public simulation services on the cloud. So that means if you want to test your own control algorithm, you can definitely do that in our simulation platform. And also, I just simply want to touch a little bit about the auto-tune. Auto-tune services is a framework. We try to use some data-driven algorithms to fine-tune some parameters in your software stack. For example, if you want to tune your hyperparameters of your neural networks, or if you want to tune some control parameters, planning parameters, etc., you have this closed loop where you have the parameter optimizer, meaning that there's a optimization process running to iteratively optimize your parameters and verify that in our simulation platforms, because we have the vehicle dynamic models. We know how exactly those models were working as if they were deployed on the real vehicles. So by iteratively testing and verifying and fine-tuning your parameters, so eventually you're going to achieve a very optimal set of the parameters you can deploy on the vehicles. So compared to like in a lot of scenarios where you have to handcraft and hand-tune your services, your parameters. So this framework that will definitely improve the tuning efficiency and also will drastically improve the final performance of those modules that you actually want to fine-tune. So, and also this technology was also published in the ACC 2021. So other than the software and the algorithms, neural networks, models that we're developing, the Apollo also has the data pipeline cloud services that we provide to our partners and also the other developers around the world. For example, so right now we have like a bunch of services running on the public cloud. Meaning that you just simply provide your data, and those public services will be able to generate some of the results using our cloud service resources and computing, especially the computing resources. One example is that, for example, if you want to tune your control parameter, just simply use the data recorder that we provided in our Apollo open source software platform, and just upload the data, and then eventually you'll have optimal control parameters that are fine-tuned, and also you can just download them and deploy that in your vehicle or in your moving devices directly. Or for example, another cloud services is the virtual link service, where because we know that making an HD map, the high definition map, is very costly and also takes quite a long time. But if you just want to verify how good your vehicle is running on some of your test bed, you can just simply by collecting some of the localization data, and our cloud service will be able to generate a pseudo HD map for you to experiment and test your vehicles in your test bed. So all those services are provided to our customers and developers and users around the world to help them facilitate the research and development of the autonomous driving technologies. So overall, the Apollo, in addition to the software, the open source software that we provided to our users, the goal of our mission or our ambition is to closely work with our users, our commercial partners, our all the developers around the world, because we believe this is the autonomous driving is such a big industry, and also it's such a complicated system. So we need all the participants in this industry to work closely together to completely reshape the mobility of the future. Yeah, that concludes my talk. Thanks, everyone.
Okay, if no question from audience, I have one. So Jinghao, you mentioned that you have the open cloud services and you can do, for example, you utilize like a point period model training. For example, if like students, if the students want to do this kind of pipeline, for example, they train the point period services, and want to deploy this kind of model to the maybe like the model deploy to the Apollo platform. Do you have some mini Apollo or mini modules for them to test the algorithm? Does the open cloud services has this kind of thing? Maybe let students to test some of the new models they trained, either using simulation or using the real code?
Yes, so that's a very good question. There are different ways to test how the new models generated by our pipeline is. First of all, our pipeline will definitely have a benchmarking, a visualized performance benchmarking numbers for you to share with you, like how good the new model is after you submit your data and got the new model trained. And on top of that, you can actually plug your model in your source code and submit this to the our simulation platform and see if you, like, for example, your scenario pass rate increases or not, or if you failed some of the cases, what's the reason for the failed cases. And eventually you can deploy the models just simply by copy and the models and replace the existing ones and to test that on the vehicles. There are different stages where you want to test how good your model, the new model is. It really depends, how readiness you are to test those new algorithms.
Okay, so for this open cloud services, it's free open to students, or is there any permission to get access for the open cloud services?
I think some of the services are free, and some of the services are required a little bit a small amount of fees. It depends on what kind of services that you want, and also depends on your agreement with the Baidu, or your partnership with Baidu. For example, I believe we do have some testing quotas for our partners to use our services for free during a short period of time. And then if you want to keep using it, maybe you have to pay some amount of fees.
Okay. Last question. So your DKIT platform is very interesting. So are they available in the US, or it's only available in China?
Right now it's available in China. I think they have the plan to expand that to the US as well, and they're actively talking to some of the partners who will have the capability of manufacturing those DKIT. Yeah, they're in the process of doing that.
Okay, it's very cool devices. Yeah, thank you.